Hello students, so let's try to solve one more problem from mechanics, and this is from the book IE Irodov. You know that Irodov is one of the best book to understand physics, and this has a lot of numericals which you have to solve to understand the basic concept. So this question is all about to understanding the friction as well as reactionary forces. So what is this particular problem? So this is problem number 1.61. So let us try to understand what is given there. The two touching bars 1 and 2, so this is 1 and 2, are placed on an inclined plane forming at angle alpha. So this is an inclined plane. So there is an angle alpha. At these two bars are at the angle alpha. The masses of bars are equal to m1 and m2. So these two masses has a mass m1 and m2. The coefficient of friction between inclined plane and these bars are k1 and k2, where k1 is greater than k2. Then what we have to do? We have to find the force of interaction between these two bars. So we have to find the force of interaction, and then we have to just find what is the minimum value of alpha such that bars will just start to sliding. So this is wonderful problem, and this is very basic problem. So let's try to solve this particular one. So let me first draw this particular problem. So this is my wedge, and this angle is alpha. This is inclined plane. So this one is mass m1 and another is mass m2. And we have to just go for the free body diagram. We can assume this is my x-axis. So this will be my weight m1g. This will be my weight m2g. And in this direction, we have my force. That value is equal to m1g sine alpha, and for m2g the force is also into this direction. That value is equal to, I am writing here, that value is m2g sine alpha. And look at here, if we will see the reactionary force, then what will happen? This block will push m1 into this side, so this will be my reactionary force R1. From the Newton's third law, this will also push into this side, so this will be R1. And you can see these two forces are equal in the opposite direction, so we can use these two forces as internal forces if we are assuming this as my combined system of mass m1 and m2. And also we have this, in this direction we have m1g cos alpha, and in this direction we have m2g cos alpha, and this will be my normal n1 and this will be my normal n2. So now we have to just write the equation of motion. So what is the trick? The trick is very simple. I will not write equation of motion separately for m1 and m2. Rather, I will write my equation of motion for combined mass m1 and m2. So what will be this equation of motion? The equation of motion is m1g sine alpha plus m2g sine alpha, and yes, there is a frictional force, so the frictional force will act into this direction, in opposite direction. So we have the frictional force, that is F1 minus F2, and this value is equal to m1 plus m2 into acceleration A. So I have just assumed that this two body is coming with the acceleration A. If I am assuming these two body as a unique body, then this reactionary force will treat it just like as an internal force, so I can avoid to writing into the equation of motion. So what is my F1? So I can calculate F1, that value is equal to K1 into m1g cos alpha, and F2 is equal to K2 into m2g cos alpha. And what is m1g cos alpha and m2g cos alpha? n1 is equal to m1g cos alpha, n2 is equal to m2g cos alpha. So these things are very simple. So what will be my equation of motion? So my equation of motion is all about m1g sine alpha, and you can just take it common also. So this value is equal to m1 plus m2 g sine alpha minus we have k m1 plus k1 m1 k2 m2 into g cos alpha by we can have m1 plus m2 is equal to a. So this is your acceleration of a combined body. And if it is acceleration of a combined body, it is also acceleration of mass m1 as well as mass m2. Now we have to find the reactionary force. So how we will go for the reactionary force? So let's try to go for writing the equation of motion for m1 separately. When we are going for m1 separately, then what will happen? This value is equal to m1g. In this direction we have frictional force. This value is equal to m1g cos alpha. This is your f1. This will be your normal. And this is your m1g sine alpha. And yes, this block m2 is pushing this one with reactionary force R1 and R, whatever you can use this. So we have to calculate this value R1. So what will be my equation of motion? My equation of motion is equal to m1g sine alpha plus R minus m1g k time m1g cos alpha is equal to m1 into a. And from there we can find the value of R. So what will be the value of R? The value of R is equal to m1a minus m1g sine alpha minus minus this value is equal to minus plus k m1g cos alpha. And we can get the value of a here, so we can just go for the another page where we can have R is equal to, so R is equal to m1, so I am just using this space. So R is equal to m1a minus m1g sine alpha plus m1g into k1 cos alpha. So in the previous part we have to go for k1. This will be k1. So let's try to go for next part. So this is my equation. So now I will put the value of a. So R is equal to, we have this particular R, that value is equal to m1. The value of a is equal to m1 plus m2 g sine alpha, and we have minus k1 m1 plus k2 m2 g cos alpha, and by we have m1 plus m2, and this value is minus m1g sine alpha plus k1 m1g cos alpha. So it look very lengthy, but don't worry, if when you will calculate it, lot of thing is going to be cancelled out. So let us try to see what is going to happen. And yes, this m1 is going to multiply with whole this thing because this is your acceleration. So let's try to go for this. So R is equal to m1 plus m2 g sine alpha minus m1 k1 m1 plus k2 m2 g cos alpha. So this value is equal to g cos alpha minus this m1 m2 is going to multiply with this one. So m1 plus m2 g sine alpha plus again it is going to multiply with this one m1 plus m2 k m1g cos alpha, and yes, in the denominator we have m1 plus m2. Now it's look very clumsy, but don't worry, see it in a very efficient way, the lot of thing is going to cancel out. Which thing are going to cancel out? This is m1 into m1 plus m2 g sine alpha. m1 into this particular thing is going to cancel out. Okay? And again you can see k m1g cos alpha into m1. So k m1g cos alpha into m1. So this thing is also going to cancel out. So what will happen? Only few thing is there. So what will be my reactionary force? My reactionary force is equal to m1 m2 g cos alpha 1 plus k, sorry, this value is equal to, so you will just go for k1 minus k2 upon m1 plus m2. So this will be your reactionary force between the two particles. So this is wonderful problem. So only this part is there and this part will be there. These two part will be survive there. So this value is equal to k1 and there's k2 is there. So k1 minus k2 will be going to survive there. Okay. So this minus sign will be there. So this will be plus. So you have k1 minus k2 and this thing you can take common. So this will be your reactionary. So you students, the thing is that whenever you will solve the Irodov problem, you have to do calculation in a very efficient way. Otherwise you will puzzle yourself once you will go for unnecessary equations. Okay. Now the next question is that what is the value of alpha such that just both the particles just going to slide down. So let's try to go for again for the acceleration term. So once we are going for the acceleration term, so what is my acceleration? My acceleration we have already calculated, that is m1 plus m2 and this value is equal to g sine alpha minus k1 m1 plus k2 m2 into g cos alpha, and here we have m1 plus m2. At that particular critical value of alpha, the minimum value of alpha, what will happen? The acceleration will be 0. So at minimum alpha, that it is just going to slide this particular thing, that the whole body is going to slide. So this particular thing, so acceleration will be 0. So we have to just talk about the thing when it is just going to slide down. So what will happen? We can take the limiting case that up to that limit acceleration is going to 0. Then easily we can find the value of tan alpha. So tan alpha is equal to, we can easily calculate this particular thing. So tan alpha we have k1 m1 plus k2 m2 upon m1 plus m2. So this value is equal to your tan alpha. At this particular value of alpha, tan tangent of the alpha, both the block is just about to slide for the limiting case. This is for limiting case. Okay, so we can easily calculate all this thing. So students, it's a wonderful problem. Just try to solve yourself. And once you will solve this type of problem, then obviously you will get confidence and you can solve much better problem in a very efficient way. Thank you.